So this example is having us find a C value, which is our initial amount, and A, which is either going to be a growth or decay factor, so that f of x equals C, a to the x models the situation below. So these are three separate problems that we're going to come up with a function to represent. There are initially 3,500 bacteria, so I know what C is, and I can go ahead and plug that in. Times, and now I need to find A. This sample doubles in size every hour. So double implies our factor, our growth factor of 2, and then our variable to the x power. So you can try this out and just make sure that when x is 1, for example, after 1 hour, 3,500 times 2, that'll give me 7,000, which makes sense. After 1 hour, it's supposed to double in size. You can keep going to double check, so to speak. For part B, fish population is initially 3,000. Okay, so I'm going to start out with f of x equals 3,000, but decreases by 5% each year. Now that percent is a rate. We're going to change to a decimal, 0.05. Move the decimal over, it's behind the 5, 2 places to the left, 0.05. And it's decreasing. We're looking for the A value. So this is now a decay function, and we go back to our notes, and to find A, it's 1 minus the rate, 0.05. So in this case, our A value is 0.95. So it's 3,000 times 0.95 to the x power. Notice, again, it's a decay function. We're decreasing by 5%, so we should expect that our number inside here is a number less than 1, but bigger than 0. For part C, the population of California was 37 million in 2010. That's our initial amount that we're starting with. Increases by 1.3% each year. So again, we're assuming that we're starting in 2010. That's going to be our initial amount. So 37 million. Now our A value, again, is not 1.3 because that's a percent. So that's a rate that needs to be converted to a decimal. Move the decimal place over 2 to the left. Still a rate. We're looking for A. And our formula for A, when we're looking at a growth function, is 1 plus the rate. So our A value of 1.013 becomes our A value. And then raise it to the x power. Again, you can always plug in numbers and see what happens after year 1. Or in 2011, you would not put in 2011, but you put in x equals 1 or x equals 2 for 2012, and then come up with a value for the function. Okay. We're going to take a look at this chart. We'll fill in a couple of values, and then I'll have you fill in the rest on your own and check them with your classmates. The initial value for this particular problem is our C value, which is 52. We look at the A value to determine whether it's a growth or decay function, and our A value happens to be 0.02, which is a number less than 1. So we're looking at a decay value or decay function. The growth or decay factor, remember, factor means what are you multiplying by? Factor is a multiplication problem part here. So we're looking at our factor of 0.02. Our growth or decay rate, now that's a percent. And remember our formulas. We already said this is decay, so our formula for A was this. A equals 1 minus R. Well, I know what the factor is. It's 0.02. 1 minus R. So I can solve for R to get the rate. Subtract 1 from both sides. I'm going to squeeze this in here. And if I subtract 1, you can use your calculator if you need to, 0.02 minus 1 is going to get you a 0.98, and it's going to be negative equals negative R. So positive R then is going to equal positive 0.98. Now they want the rate as a percent, so I need to change 0.98 to 98%. Next one's a little bit more of a challenge because you're having to think backwards. For this one, I was given the function and I could pick out the information given the function. This one's a little bit more of a challenge, but I know what my initial value is. So I can come over here and start out with, R of t equals my initial amount, 920. I know what my growth factor is. Because it's bigger than 1, we're growing, so we can put in growth here. And the factor is what I'm multiplying by, 1.05 raised to the t power, or whatever variable you used in here. If you used an x, then you'd use the x as the power. Now, this we've said is growth, so I have to think about what was the formula for my growth factor, and that was A equals 1 plus R. I'm looking for R, the rate, so I'm going to solve for R. I'm going to subtract 1 from both sides. A minus 1 equals R. My A value is this. That's the factor 1.05. So if I take 1.05 minus 1, that's going to give me 0.05. Now that's a decimal. I want it as a percent. So as a percent, this would be 5%. Move the decimal to the right 2 places. So this has a growth rate of 5%. I'll let you finish the rest of this chart, fill it in, bring it to class next time.